All right, here problem 9, we're looking at balancing this particular chemical reaction in acidic solution and then balancing it in basic solution. The interesting thing here is since this occurs in an aqueous solution that is acidic, we can use either H plus or water in order to balance our chemical reaction. So it's different than the first semester class where you're told not to add any species in order to balance. Here in fact, we want to. If I go through and assign the oxidation number to the atoms, so the important oxidation changes that happen here is that we have this nitrogen that goes from being the +5 state to being in the +4 state. The oxygen, which started out as neutral, goes to +5. The approach that I like, and the one I'm going to show you, is to balance each half reaction and then balance the entire thing by combining the half reaction. So let's just start with the nitrogen half reaction here first. Okay, we have nitrogen in the +5 going to nitrogen in the +4. That means it must have received an electron. So thus far we've just added an electron in order to balance the oxidation number of the nitrogen atom. Next, we are going to add ultimately some water in order to balance the number of oxygen atoms. NO2 plus 1 water molecule. Okay, now we have 3 waters. We have 3 oxygens and 3 oxygens. Okay, now though, we've put the left-hand side, it doesn't have any hydrogen atoms, so we need to add those in. Okay, and now if you go through and do all the counting, they have the same charge, no charge and no net charge on either side, same number of oxygen atoms on either side of the air, and same number of hydrogen atoms, same number of nitrogens. So we'll hold on to this one. We'll use it here later, but we've balanced the first half reaction in acidic solution. Now let's start on the second one. So we've got I2. Each of those iodine atoms has no charge, and it is going to IO3 minus. Before we do anything else, let's balance the number of iodines just by putting a 2 out there. So we balance the number of iodines. This is iodine in the 5+ state. This is iodine in the 0 state. To bring those iodines to the same charge, we would need to add 5 electrons, and there's 2 of them, so 5 electrons 2 times would give us a total of 10 electrons. So we balanced the number of iodines, we balanced the oxidation number of each iodine atom. Now we need to balance the number of oxygen atoms. So I2 plus, I'm going to add, I have 6, 2 times 3, I have 6 oxygen atoms, so I'm going to use 6 water molecules. And now I'm going to balance the hydrogens by adding just H pluses in. Okay, I have 12 hydrogen atoms, so I'm going to add 12 H pluses. And this is all balanced now. 2 iodines, 6 oxygens, 12 hydrogens, 12 hydrogens. There's no charge over here, and there is 2 times 1. There's 2 minus, plus 10 minus gives me 12 minus, plus 12 plus gives me a neutral charge on both sides. So those guys are good to go. Well, we have one little problem we need to solve before we marry these two together to give us the overall reaction and solution. And that has to do with the fact that this top reaction up here, it consumes 1 electron, while this one down here produces 10 electrons. All right, so we've got the top reaction here with the nitrogen properly balanced. We've got the bottom reaction here with iodine properly balanced, but they're not ready to mesh together because this reaction consumes 1 electron, this reaction produces 10 electrons. But we can take a properly balanced reaction, just multiply through by any constant, and it'll still stay balanced. So let's just do that. If we take now 10 nitrates and 10 electrons, and now 20 H pluses, and 10 NO2s, and 10 H2Os. Now these are properly balanced, 10 electrons and 10 electrons. I'll just go ahead and rewrite this guy down here. Okay, and now we can do some cancellation to finish this out. So 10 electrons as a reactant, 10 electrons as a product. 6 waters and 10 waters. So it doesn't cancel perfectly, it leaves 4 waters left over. 20 H pluses and 12 H pluses. 12, the 20 now becomes 8. And otherwise we look like we're in pretty good shape. 10 NO3 minuses plus I2 plus the 8 H pluses that survived reacting to make 10 NO2s plus 4 waters plus 2 IO3 minus there we go. This should be properly balanced now. So 10 minuses, this is 10 minus, this is 8 pluses, so this side of the equation has a 2 minus charge left overall. Neutral, neutral, and 2 times 1 gives me 2 minus, so it is balanced both in atoms and charge.